Hi, today I'll be talking to you about investing money, in particular drawing and describing simple interest graphs. A simple interest graph will have time on the horizontal x-axis and I, or interest, earned on your vertical y-axis. So we've got our plane, which go this way and that way, so that's the y-axis, and this would be the x-axis. We have our interest earned on the vertical, so as you earn more interest, the line graph will go up, and as you go along with time, your line will go across, because time will be on the x-axis. To draw the graph, we're first going to make a table of values for I and n, and using those values, we will plot those points, and then we'll be able to join them up and get a straight line. Now, the reason I know that this line will be straight is because it is a simple interest graph, which means the amount of interest you earn every period will be the same, which means you will have a constant gradient or a constant slope, which is what it says here. Here's an example. If we use this table here, which tells us depending on how long we have an investment, we get a different amount of interest. Tyler here has $50,000 to invest in a fixed term deposit, which means once you put money in there, you can't touch it for as long as you say. So that's your fixed term. Draw a separate graph to represent the interest earned given these investments over 12 months. So that's 1 year. Now, because this is an interest graph, we're going to have interest on the vertical y-axis and we're going to have time on the horizontal x-axis. The first part of the question here says, find the interest earned over a fixed term deposit of 3 months. So 3 months is in here, so we're going to get 7% per period, or per annum. Here's a prepared graph. First of all, we need to construct our table of values. So using our formula, I equals to PRN, or interest is our principal multiplied by the interest rate and multiplied by the periods. Substituting our values in, we get $50,000 multiplied by 7%, or 0.07 in decimal form, multiplied by n, our number of periods. Using the calculator to simplify that, we'll get 3,500 n. So this is our equation now. Our interest earned would be 3,500 for every period. Now, using our table of values, I've done it upside down. Sorry. The n on the top, because that's our independent variable, and our interest on the bottom, which is our dependent variable. For 0 years, 0 terms, we will get 0 interest. That's pretty easy. We substitute 0 into there. I'm going up in even numbers, so 2. Substitute 2 into here, 3,500 times by 2 is 7,000. So after 2 years, you will earn $7,000 of interest. 4, if you substitute 4 into here, you will get 3,500 times by 4, which would be $14,000. And 6, if you substitute n equals to 6, 3,500 times by 6, you should get $21,000. Now, I have 4 points. You only really need 2 to make to draw the line, but I've done 4 for good measure. Now here's our graph. We've got our vertical axis here for the interest earned, and we have our horizontal axis here for the time periods. Plotting these points, 0, 0, that's at the corner, to 7,000. So 7,000, I'll just say, is about there. So that's over about 2 and 7,000. For 4, it'll be about 14,000, which I'd say is about here. For 6, it'll be 21,000. So going up, I'd say it's about there. Now, assuming you had a ruler and you measured this up correctly, you would then get a straight line that looks something like that. And the whole point of drawing this is using the graph, we would be able to stipulate or to guess what we'll get in the future. So after 8, if we go up, we'll get roughly $30,000 or wherever that is. So if you can read that up, you can go there, and for 10 you can go up, and wherever it hits you read across. Now that was part A. Part B is our fixed term deposit for 6 months. So 6 months would mean we would be in here, so we get an interest rate of 7.5%. Here's another graph that I prepared. Using the same formula, interest equals the principal times by the rate times by the time periods, we would get $50,000 times by 7.5%, 0.075 in decimal form, multiplied by n. In the calculator, we get 3,750 n. So every term, we will earn $3,750 of interest. We then need to construct our table of values. Again, at 0, we will earn $0 of interest. At 2 terms, we will earn 7,500, substituting n equals to 2 there. At 4, it will be 15,000, and at 6, it will be 22,500. So you would substitute those n values into here, into your calculator, and we will get those interest values. And at this point, it's much the same as before. We plot those points. 0, 0 was at the origin. 2, 7,500. It's a little bit higher than last time. 4 and 15,000. 6 and 22,500. So if I draw this one, we also get a straight line. Now you can't see it, but because I've had this page underneath, there is a faint line here where I've drawn the other one. And that would actually have a slightly less and reduced gradient because the amount of interest you earn is less. So now that our interest rate is higher, our gradient or our slope will go higher, like so. Finally, part C, we have a fixed term deposit for 12 months, which is here. So we should earn an interest rate of 8.1%. Following the same procedure, we have our interest formula, I equals to PRN, $50,000 times by 8.1%, 0.081 in decimal form, multiplied by n. Using our calculator, we find that every period we will earn $4,050 worth of interest. Again, the next step is to create our table of values. At 0, we similarly earn $0 of interest. At 2, so at n equals to 2, we would earn $8,100 of interest. At n equals to 4, we would earn $16,200 of interest. And at 6, we would earn $24,300 of interest. Now, these values aren't quite as nice as before, so I won't be able to draw it as accurately. However, 2, 8.1, that's even higher than before. At 4, it will be 16,200, and at 6, 24,300. So again, I've got my straight line, and once again, I can see on my page those faint lines where I've drawn the previous graphs, and this one has an even higher gradient. So this one at 8.1%, at 7.5%, and at 7%. So those were the differences. I'll just pull up those other graphs. So they all look pretty much the same here, and those are our 3 graphs. So this was the this one here was the 7%. This one here is the 7.5%, and then we have our 8.1%. And they all look very similar. However, the gradient is in fact different. If you had drawn this graph a bit more accurately on the side, you would have seen that difference much more clearly.